So here's a few examples of solving linear equations, and we'll start with basically the one-step equations. So we'll have to do one step to find the solution. So in this case, we have to remember that our four basic binary operations are addition, subtraction, multiplication, and division. And the way I do this is I just use the opposite operations. Opposite of addition is subtraction, opposite of subtraction is addition, multiplication, opposite is division, opposite of division is multiplication. This is more of a traditional way of doing it, but it works for me. So we're always trying to, when we solve, when it says solve for x, I guess I should write over here, solve for x. So the directions on all these would be solve for x. And it could be y or z, whatever. I just use x because it's, again, traditional. It's easy to write. Okay, solve for x, which means what we want to end up with is we want to end up with x equals. So we want the x all by itself, and then we want the solution on the other side. So we always want to end up with x equals. We're trying to solve for x. Now it could be like this, or it could be like this. Something equals x. So it can be on either side. And that's the solve for x, okay? So we look at our equation. We want to solve for x. We want to get x all by itself on in this case, the left side, because that's where it's at. So I want to remove the 4. So I just ask myself, how is the 4 joined to the left side of the equation? Well, you always look at the sign in front of it. The sign is negative, so what's the opposite of negative? Addition, and that tells you what you're going to do. So you're just going to add 4 to both sides. Now, when we studied our basic properties of real numbers, we know that these are what we call additive inverses. So negative 4 plus 4 is 0. And then we know that that's the identity element under addition. So x plus 0 is just x. So my answer is just x on the left. And on the right is 6. Now, you always want to remember to line up your equal signs, because that'll help you. And you always want to remember that what you do to the left, you do to the right. Okay? So I could put my pencil there. If I look, I added 4 to the left, I added 4 to the right. Okay? That's what you do. The equal sign is kind of like the middle of a teeter-totter. You always want to balance it. So what I do to the left, I must do to the right. Don't do the same thing to the left twice. It's not going to make it won't keep in balance. So what you do to the left, exactly what you do to the left, you must do to the right. Side of the equal sign. So try to keep that in mind. And if you line up your equal signs, it makes it a lot easier. Okay, if I take a look at number 2, x plus 3 equals 7. So I want to solve for x. I want to isolate the x. So I want to remove the 3. It's joined by addition. What's the opposite of addition? Subtraction. So I'm going to subtract 3 from both sides. And again, remember, I'm doing the same thing to the left and to the right of my equal sign. 3 minus 3 is 0. X plus 0 is just x. So I've got x on the left. And that equals, and 7 minus 3 is 4. Now you could have some negative signs, and that's what we talked about sign numbers in the previous video. So you might want to make sure that you review that, because we will have some with negative numbers a little bit later. But for these basics, I just want you to get the idea of what's going on. Okay, number 3. This is x over 3, or x divided by 3, the quotient of x and 3. So that's going to be division, and that equals 4. You could also write it like this, 1/3 of x equals 4. In either case, since the 3 is on the bottom, it's joined to the x by division. And the opposite of division is multiplication, so that's how I'm going to remove it. So I'm going to multiply both sides by, in this case, 3. Now, from our properties of real numbers, this is going to be the actual multiplicative inverse. 3 over 3 is 1. 1 times x is just x. So, and then 4 times 3 is 12. So there you go. And then number 4, this is, if you were going to read this out, it would be 2 times x equals 12. I want to solve for just the x. I just want the x all by itself. So I have to remove the 2. The 2 is joined by times by multiplication. The opposite of multiplication is division. So that's what I'm going to do. I'm just going to divide both sides by 2. Two over 2 is 1. Again, that's the multiplicative identity. So x, 1 times x is just x. And then 2 divided by 12 is just 6. Okay. Now, sometimes we see a problem like this, and it's kind of a special case. There's always 2 ways to do these. So if I saw something like number 5 where I want to solve for x, and I want to get rid of the 2 is joined by multiplication. The opposite of multiplication is division. Well, when we have a fraction on the right, if I've got 1/3 and I'm going to divide it by 2, well, I've got to use the reciprocal. What we do is we don't really divide fractions, we invert and multiply. So we would multiply it by 1/2. So sometimes that's a little bit more difficult. So what we might do here is we might use a multiplication of the inverse. So in other words, if you see something like this, rather than trying to divide by 2, which can give you a little bit of a problem over here, just multiply both sides by 1/2. Now that's the same thing. If you multiply by 1/2, it's the same thing as dividing by 2. In other words, if we look over here and we say, what's 1/2 of 10? That's going to be equal to, well, 2 goes in there 5 times. And then what's 10 divided by 2? So 2 goes in 10 5 times, and 10 divided by 2 is 5. It's the same thing. So multiplying by 1/2 and dividing by 2 is the same thing. So in this case, it's kind of like, instead of dividing by 2, I'm going to multiply by 1/2. That's going to remove the 2. So it's the same thing as dividing by 2, but it's going to be a lot easier to take care of this fraction. So 1/2 of 2x is just x. That's 2 over 2, which is 1x. And you see how much easier this is, because instead of saying 1/3 divided by 2, it's just 1/3 times 1/2. Numerator times numerator is 1. Denominator times denominator is 6. So you see you get 1/6. So that's just a little bit easier approach. Okay? And then, so you can always pause these and go back if it's going a little bit too fast. I want to do one more. And this is it's kind of a special case when we see these a fraction with a numerator and a denominator times x equals 9 in this case. We could also see this written as 3x over 2. It's the same thing. Then instead of, we could do 2 steps. We could multiply both sides by 2 and divide by 3. That's 2 steps. But we can use our reciprocal property, which is multiplicative inverses actually. And we can just multiply both sides by the multiplicative inverse of 3/2, which is 2 over 3. And what I do to the left, I have to do to the right. Let me emphasize that, okay? On all these problems, what I did to the left, I did to the right. I'm going to go back and just emphasize that. See? I multiplied both sides by 3. Here I divided both sides by 2, both sides of the equation. And here I multiply both sides by 1/2. So remember, what you do to the left, you must do to the right. Okay? So over here I'm going to multiply both sides by 2/3. Is that okay? And then 2 times 3 is 6, 3 times 2 is 6, 6 over 6 is 1, or you could cross reduce the 2's, and we end up with just 1 times x, which is x. Now you could say 9 times 2, because these are like fractions, and you could think of it as numerator times numerator, denominator times denominator. So you could say 9 times 2 is 18, and 1 times 3 is 3, and 3 goes in 18 6 times. You could do it like that. Or you could just say 3 goes into 9 3 times. 3 times 2 is 6. So in either case, you're going to get 6. So this is just another way of doing it if you want to multiply it out, or you want to reduce, pre-reduce. In other words, they call it cross-canceling, but you're reducing. 3 goes into 3 once, it goes into 9 3 times. 3 times 2 is 6. So this is how we can handle something like this, and we could do it in one step rather than 2 steps. Rather than multiplying by 2, then dividing by 3. We could save ourselves a little bit of time.